Hello everyone, I'm Nikhil Nandagopal, and I'm going to be talking to you about how you can optimize your engineering time with low code. I'm the founder and CPO at AppSmith, which is a low code tool for developers to build internal tools really quickly. But I myself have been an engineer for the last decade, and I've built multiple internal tools in different companies such as Flipkart and CureFit, and I've seen how difficult it is to build these tools as an engineer. So the one point I want to make is that dry principles apply here as well. As engineers, we're always taught to do not repeat yourself. And this applies to our code to make it really reusable so that we can quickly build new features as well as maintain our code base. But why do we spend so much time building repetitive dashboards and custom CRUD forms over and over again? We know that over 40% of a company's engineering bandwidth is actually spent on internal tooling, and unfortunately, internal tools are really repetitive. Developers really dislike working on internal tools because there's no real innovation in them. They're largely the same components working with the same CRUD operations, all stitched together in slightly different variations. So how can we improve this when our developers are actually spending 40% of their time being really unhappy? But to start with, what are internal tools? Now, internal tools are custom pieces of software that businesses use to allow their business teams to interact with their data. Now, these software generally begin as scripts and spreadsheets, but they quickly evolve into custom admin panels like the one you are seeing today. So why do we need these internal tools? Today, with the boom of SaaS, all of our data is now fragmented across different data sources. We have our payments information in Razorpay or Stripe. We have our customer support information inside Freshdesk or Zendesk. And at the same time, we have all of our user and order information inside our own databases such as Mongo and Postgres. But how do all of these data sources talk together? So that's where internal tools come in. Internal tools allow you to interact with your data from different data sources, all in a single dashboard. You can have customer support tools that talk to your support information inside Zendesk and then refund orders to Razorpay. You can also have offer configuration tools that create offers inside your database as well as send them to your users via SendGrid. And you can even have cataloging tools that work with your catalog data inside Elastic, but also update images inside S3. All of this are possible only because of internal tools, and they help make a business's life a lot easier and smoothen the internal processes. So great, these tools are really useful. What's the problem? Why are these such a horror story? Unfortunately, these internal tools are extremely mundane to build. They consist of the same set of UI components such as tables, charts, and forms, which talk to the same set of CRUD operations, which are largely read operations, aggregate operations, or delete operations. And these aren't very exciting for engineers to build. At the same time, there aren't a lot of designers or product managers involved in these internal tools, so these tools don't get the same level of attention that consumer products get. And backend developers don't like building these tools because they have to learn HTML, CSS, which is not something that they're really great at. Even front-end engineers don't want to spend time beautifying the UI UX of these tools because they really care about working with the business logic of the core application. Now, internal tools are constantly evolving, and they need to keep changing to keep pace with your business. And this means that these internal tools have a lot of new requirements that come up every day, which means that they have a lot of maintenance, and that makes it very hard for engineering teams to focus on the core problem of their business and not divert attention to these internal tools, because internal processes are constantly changing along with the business. Now, we spend so much time building these internal tools, but unfortunately, because they don't get the same level of attention as consumer products, these tools quickly evolve to becoming so complex that business teams themselves can't use them without having engineers in the room. I myself have worked with business teams that needed me to help them configure offers because they were worried that the wrong offer might go out to the wrong user group and thus lead to a loss in revenue. So eventually, after investing many years building internal tools, we ended up coming back to the same state where we were in, where a lot of development time was still going into the usage of these internal tools, and that defeated the purpose of building them in the first place. So how has this still not been solved? The problem is that these tools need to be extremely custom to every business. Even in similar businesses like food delivery, we've seen that two competitors could have widely different internal tools, even though their products are fairly similar. And this is because both their businesses are trying to evolve in different ways, and their internal operations need to evolve to match those. At the same time, the SaaSification of different applications has led to a rise in the fragmentation of data, and the older solutions simply can't match up to this. So what are our solutions today? One of the most common solutions is to build it from scratch. We could spin up a Node server along with maybe a React frontend and maybe even add a Bootstrap template. But unfortunately, this would take a lot of time and it would be very difficult to maintain in the long run. The UX would also probably not be very good because we wouldn't really have any designers involved in the process. And it would be really difficult for us to integrate with custom libraries such as QR code scanners and other third-party data sources if we didn't have a lot of front-end knowledge. Our other option is to go ahead and use something off the shelf. We know that we have Rails admin or Django admin or even something like Forest admin. And this is great to help us get started very quickly, but unfortunately, it takes a lot of time to customize these tools. Eventually, we've seen that the time it takes to customize and maintain these tools overshines the benefit of getting something out of the box. And remember, these tools need to be custom to your business because the UX really matters to your internal teams. Our other option is to try out no-code. Now, no-code tools have professed this entire paradise of the citizen developer, but unfortunately, we've seen that business teams find it really hard to build complex tools that talk to your data. This is because business teams rarely ever understand the type of data that's there inside your database, and without that, it's really hard to create custom business logic. So no-code tools always have a ceiling inside of them where if you need a custom component or you have a custom piece of logic you need to add, it's really difficult to use them. No-code tools also unfortunately don't really integrate with your development workflow, which means it's not great for engineering teams. You can't review the code that's being changed, you can't integrate them with your CI/CD pipelines, and often you can't even have backup and restore or version control. And most important of all is that all of these tools need to talk to your own customer data, which means that this is mission critical and very important for security. So no-code tools unfortunately don't have the option to self-host them, so there's always a question of how secure are these tools. The other option is to go low-code. So AppSmith is an open source low-code platform for developers to build internal tools. The great thing about AppSmith is that it's security first. So you can go ahead and self-host it inside your own VPC without having to worry about data ever leaving your firewalls. At the same time, it's open source, which means that you can easily audit it as well as make changes to it whenever you feel that you've hit a ceiling. And AppSmith also comes with JavaScript, which means that you can write JavaScript inside the platform to write any kind of custom logic. So you never feel that you are missing out on the benefits of coding. AppSmith also gives you these reusable building blocks called widgets, which you can use to drag and drop and build your UI. So even if you don't know HTML, CSS, it's really quickly to build an application out of the box. And the thing that we're most proud of is that AppSmith works really well with Git. This means that you can commit your code, you can raise pull requests, and you can integrate with your CI/CD so that your developers always feel at home. Now let's see how it works. So AppSmith has two layers. The first layer is an IDE layer. Now the IDE layer comes with a UI builder that has custom widgets that you can drag and drop on the screen to build any kind of UI that you want. It ships with over 40 widgets that are handpicked and crafted to make sure that any kind of UI is possible and all of the internal tooling use cases are taken care of. The second bit is that it also comes with the ability to talk to your data sources. So you can connect to your databases directly or any kind of internal API behind an authentication mechanism. You can easily connect to these REST APIs and write queries on top of them to query your data and update them. And the third block is the JavaScript block. So the JavaScript block helps you write the logic between these queries and the UI building blocks so that you can arrange them in any way that makes sense to you. You can write logic to parallelize queries, you can write them to have conditions between UI elements, you can write them to create authentication flows and authorization flows. All of this is possible inside AppSmith. The second layer is the platform layer. So the platform layer consists of access controls out of the box. So here, all of AppSmith applications are secure by default. You can invite users to your application, and only invited users can ever get access to them. You can also deploy your applications with the click of a button. So clicking on deploy will automatically host the website for you, and you can give this website access to all of your users. And also, we have a collaboration feature where you can go ahead and comment and talk to your users in real time so that you can build your applications collaboratively with them, as well as you can sync your applications directly to any Git repo so that it can work directly with all of your current workflows. This means that you can go ahead and fork a branch, create a feature on that branch, commit it, eventually send that branch for testing, and once it's ready to be merged in, you can have it code reviewed by someone else in your team, have it merged into master, and then automatically deployed along with your CI/CD pipelines. So all of this is possible inside AppSmith. AppSmith kind of helps you save a lot of time because applications that used to take weeks are now possible to be built in a couple of hours. And at the end of the day, you get more reliable applications that have fewer bugs and better UX. Because after all, the most important thing of these applications is that it's actually helping you improve an internal process. And the best part, all your engineers are a lot happier because they're spending less time building internal tools and more time focusing on the core business requirements. So today, I'm going to be talking about a specific internal tool, which is a very common use case. It's the customer support dashboard. Let's take an example of a company like Swiggy. It probably has a lot of support tickets coming in every single day, and it has these customer support agents that need to look up all of this user information inside their Postgres DB. They need to possibly refund orders that's there inside their payment gateway, such as Razorpay. And they also need to update the users on the status of these orders inside their support desk, such as Freshdesk. Now, an internal tool like this would probably need to fetch in support tickets from Freshdesk so that it's able to display all of the ticket information. It would need to link the information from Freshdesk, maybe using the email ID, with all of the users inside the Postgres database. It would then need to be able to refund the orders to Razorpay, as well as mark the orders as refunded back inside the Postgres database, and then update the status of the ticket. So all of these different data sources need to be communicated with in a single application. So now I'm going to be demoing how we can build this tool in just a couple of hours, while this would have probably taken us weeks before. So how this application works is, we're fetching all of our support tickets from Freshdesk and displaying it for the support agent. We can go through all the emails right over here, and we can see that some people are asking about their order cancellation, some are talking about payment failures, and support agents now need to take action on this particular ticket. But unfortunately, all the order information is in the Postgres database. So we make it really easy for these agents to drill down into a user detail and search for that user automatically. They can now see all of the information related to James right over here. We can also search for other users and load the entire list of users from the database. And AppSmith can work with lots of data because we enable server-side pagination very easily. So it doesn't matter if you have millions of records or just a few hundred. Let's go back to the case of James. Now, we can see that James maybe has some incorrect information over here, and support agents might need to rectify that. So we can easily update James's information. Maybe James' last name is Dean, as well as their gender information, and hit save. So that makes it really quick for agents to service James. Similarly, we can also see all of James's past order history and see the ones that are delivered, the ones that have payment pending, as well as the ones that have already been refunded. Since this has been refunded, we can see that it's now disabled so that the support agent doesn't accidentally trigger a refund again. Let's go ahead and refund an order right now. Refunding an order talks directly to Razorpay, as well as updates our own database with the new order status. So we can now see that James' new order has also been refunded. And this makes it really quickly easy for support agents to go ahead and service all of the support tickets in a single dashboard. Now this would typically take us a couple of weeks to build, but I'm going to show you how we can build this in just a few minutes inside AppSmith. So this is the entire AppSmith interface, and we have multiple applications already created. Creating a new application is as simple as clicking a new button. Here we have an application we can call CS Dashboard, and we can rename this page as Support Tickets. The first thing we want to do is pull all of our support tickets from Freshdesk. And typically, how we go about doing that is reading the entire Freshdesk documentation and figuring out how to fetch this information. Now, integrating with SaaS providers is typically quite difficult, but AppSmith makes it very easy. All we need to do is use the curl command that Freshdesk already provides us. So I have this curl saved for us over here. We can then go ahead and create a new query and import it using curl. So AppSmith has a curl importer that automatically parses your curl commands and creates a REST API out of it. We can call this API fetch tickets. And just like that, we're able to fetch all of the ticket information for our users. We now want to display this ticket information on the screen. To do that, we can make use of all the widgets inside AppSmith. We have over 40 widgets that help you build custom UI, but the one that we want today is the table. Tables can easily be drag and drop onto the screen and resized to fit the use case. We can also make use of a text widget to just create a heading. Let's call this tickets. We can then easily style this text widget. But now we want to configure this table to read data from our query. And to do that, we can make use of JavaScript. So we can make use of the mustache syntax to open up the JavaScript world and then access our query using the query name, which is fetch tickets. So hitting fetch tickets data immediately begins to show all of the ticket information inside our table. But unfortunately, what we can see is that all this ticket information is not very human readable. And that's typically because APIs are meant to be system readable and not human readable. But that's no problem for AppSmith. We can easily go ahead and format our data by creating a simple new JavaScript object. So AppSmith lets you also create full-blown JavaScript objects so that you have the power of code at your fingertips. And here, I'm going to create a function called format tickets. And what this function is going to do is we're going to go ahead and map over our ticket API response. And only pull the fields that we really require. So let's go ahead and name this variable as ticket over here. And some of the core fields that we really need are maybe the subject of the ticket. So we can pull this from ticket.subject. We also probably need the person who sent the email. So let's add an email field and pull that from the ticket.requester.email. And to quickly check this information, we can see that it's already being returned from the query. Now we just need to bind our new JavaScript object to our table. So right now our JavaScript object is called JSObject1. So we can select that and use the format tickets function to actually format our data. And just like that, we can see that our entire user interface looks a lot better. We also probably want to look at the actual emails that are coming. So let's head back over to the JavaScript object and add a description field. The description is now coming in HTML, and unfortunately we know that tables don't work very well with HTML. But that's no problem. We can go ahead and hide this field for now and make use of a text widget that can probably render this HTML a little bit better. We now need to bind the text field to the table selected row. So let's use the table name, which is table1, and bind it to the selected row and its description field. And just like that, we can see that now the email of the user is also showing up here. Let's go ahead and also add a header for this. Maybe let's call this the email. And we can quickly style this to make it look a little better. So with AppSmith, even backend developers who don't have a great knowledge of HTML, CSS can make really good looking UI in just a couple of clicks. And with just this, we were able to fetch all of our ticket information and display it on the screen. The next thing we want to do is drill down into these tickets. So we can make use of a button widget for that. Let's drag a button onto the screen, and let's maybe call it View User. We can also style this a little bit. We now want to drill down into the user information for this particular email. To do that, we can make use of a button widget. So let's go ahead and call this View User. And we can also style it a little bit. And AppSmith allows you to configure all the properties of its widgets. So you can have various style properties as well as data properties. But now we're going to make use of the action property. So this is an event which is onClick, and we're going to configure what action is supposed to happen when a user clicks on it. Today we want to navigate to a new page. We can call this page User Details. And we want to pass this new page certain parameters in the queries. So we can go ahead and pass it an email from the table. And to do that, we can make use of the table selected row. So unclicking this button now, it's going to navigate to this page with the selected row being passed as the email. But we don't have this page created yet. So let's go ahead and do that. So let's create a new page. And in AppSmith, this is really unique that you can create pages in two ways. One was the drag and drop interface that I just talked about, but you can also generate a page from data. So let's try that out. So I already have a Postgres dataset created, and it can go ahead and scan all of my tables from my Postgres dataset. So I'm going to find the orders table right now and mark a searchable column over here. Right now I'm going to select the, actually let's go ahead and generate this for the users table. And let's mark a searchable column as email. Great, just like that we have an entire page that can perform different CRUD operations and go through our user data. So AppSmith also lets you generate applications with the click of a button and then helps you customize them very easily. So customizing these applications to your new look and feel are really easy because you have the same set of widgets that are available inside the interface as well. So here let's make some tweaks and call this User Details. We can go ahead and hide certain columns like created at, updated at. Maybe the most important column that we really want to see is the email field. And we can also see that the avatar is available here, but unfortunately avatars don't really render well inside tables. So we can fix that, that's all right. For now, let's go ahead and hide the avatar. And we can now see that this is already wired up so that the form is automatically updated based on the selected row of the table. Let's go ahead and shift these down a bit. And then we can add an image widget to display the avatar. So dragging an image widget on the screen. So image widgets are much better for this type of information from URLs. And we can link it to the table one's selected rows avatar. So just like that, AppSmith helps you work with lots of rich data, irrespective of the type of UI you want to create. Your data could be in the format of a URL, it could be in the format of text, it could be in the format of a date, but it's really, really easy to customize it inside AppSmith. Another good example of this is trying to format maybe the created at timestamp. We can easily use Moment to go ahead and do this. So AppSmith ships with libraries out of the box. We can pass this to the Moment library, and we can add a formatting option on top of it. We can format this using DDMMYYYY. And just like that, we can see that the formatting has been kicked in. So that's the power of AppSmith to kind of create CRUD interfaces really quickly. But what we also want to do right now is go ahead and look up the order details for a particular user. So to do that, we need to create a new query. So let's add a new query from the interface for the demo DB. And we can call this fetch orders. And if we want to know what does our database structure look like, we can easily inspect all of the tables inside our database right inside the Explorer. We know that right now we want to fetch orders, so let's select staff from the orders table, and let's order it by the ID, and also add a limit of maybe 10. Great. We can see that all of the orders have actually returned, but we don't just want to return the orders. We want to return only the orders that are specific to James. So let's look at the user ID field and ensure that we're only querying orders by the user ID. So we can add a where clause to this query. Let's say where the user ID is equal to the table's selected rows ID. And as we're writing this query, to ensure that we're not making a mistake, we can look at the evaluated value. So what the evaluated value does is, it tells us what is the exact value of this query before it runs to make sure that we don't make a mistake. You can think of this as live hot reloading, but for queries for all of your UI elements and for JavaScript everywhere inside the platform. So now running this query, we can see that we fetched all of the orders only for user ID 3 that's currently selected in our table. We now probably want to go ahead and show the order details, so let's make use of another table. And let's connect this to our orders query. We can also use a text widget to name this as orders. But since we want to give our users a little bit more context, we can say that this is James orders. So let's take that from the table selected row again. And this immediately tells us which user's orders it is. So that's really convenient. And we can begin by hiding some unnecessary information, such as the user ID, which we already know, and maybe even the payment ID. Awesome. So now we know how we can kind of search through data, how we can display data. But what if we need to update information? So a typical use case for this is to be able to refund these orders. So let's go ahead and add a refund button. This is a custom column inside the table, which we can now configure. And we can change its column time to button. We can call its label as refund. And because refunds are destructive operations, I'm going to mark it as red. So this ensures that every single one of these orders can have a refund button, which can now be clicked. We also probably want to make sure that if somebody has refunded an order before, we don't want to allow them to refund it again. So we can make use of the disable property in the property pane. But as you can see, this property is currently only static. To make it dynamic, we need to click on the JavaScript option and then go ahead and write some JavaScript code. So we want to ensure that the current row's status is equal to refunded. And if it is, then we're going to go ahead and disable this particular button. Now, as we can see, none of these orders are currently refunded. But if we look at James, okay, the other thing we missed out was that every time we select a particular row, we also want to go ahead and fetch the orders again. So we need to wire up our table to do that. So inside our on row selected, what we want to do is execute the query fetch orders, so that every time a user actually selects a user in the table, we can fetch all of their orders correctly. Great. So now we can see James's order, and we can see that some of his orders have already been refunded, and the button is disabled for those orders. Now, our payment information lives inside Razorpay, so we want to go ahead and call the refund API for Razorpay and wire it up to this table. To do that, we can make use of the same curl importer. So let's import a new curl command, and we already have a curl ready for us over here. So let's import this. And this REST API interface makes it really easy for us to work with any API out of the box. Even GraphQL queries work perfectly inside this. We can call this refund API. But we don't want to refund this particular hard-coded payment ID, and we want to take this payment ID from the table. So again, using JavaScript, we can say that let's take the payment ID from the new table, which is table 2, and access its selected row and its payment ID field. So AppSmith also helps you write code with the autocomplete along with the evaluated value, so you never feel like you're outside of a coding interface. Inside the body, we also don't need to hard code this amount. We can even write logic such as, let's take in the amount from the table 2's selected row. There is an order amount field, and the one thing that Razorpay needs is that the order amount needs to come in the lowest denomination. So we need to multiply this by 100 because the current denomination is in INR. So just like that, we can see that we're also making the right decision about the API we're about to run because we can see the order amount right here. But that's only part of it. Once we actually refund the amount, we also need to mark it as refunded in our database. So let's create a query to do that. We can create a new update query called, let's say, update order. And let's update the orders table and set the status to refunded. And we don't want to update every single order, we only want to update the order that is selected. So let's take it from the table 2's select rows ID. And this makes sure that we're not making a mistake because we can ensure that the valid value is there. Great, so now that we have that, we need to wire it up to this button. Doing that is really simple. We can go to the button's properties and configure the on-click to first go ahead and refund the API. The second thing we want to do is, if it succeeds, we want to go ahead and maybe update the order inside our own database. And post that, if you want to add more logic, we can just convert this to JavaScript as well and say that if the update order succeeds, then let's go ahead and fetch the new set of orders saying fetch orders.run. So now what our query is doing is going ahead and refunding the order to Razorpay. It's updating the order status in our database, and then it's fetching the new orders. So let's try this out. So clicking the refund on this particular order here has now executed. And we can see that the payment has been refunded as well as the order status has been marked. We can look at the API right over here to ensure that the refund actually triggered correctly. And our data is now consistent across our database and Razorpay. And the great thing about this is to now deploy this app and share it with our users is super easy. We just need to hit deploy, which will generate a new URL for us. And we can share this URL with our users very easily. So we can gain access to all the user information over here, as well as we can share this with our users. So sharing it will allow users to get an invite from AppSmith to be added to this dashboard. And we can also make it public. Remember that all applications are secure by default so that nobody can access them without an invite. AppSmith also ships with real-time collaboration features. So you can leave a comment anywhere in the application and tag people saying things like, hey, could you help add a new field to this table? And instantly your teammates will be notified of the changes you require, and they can go ahead and make those changes as well as approve them. AppSmith also works with all of your current development workflows because it integrates with Git. So you can connect with Git right here. You can paste your Git URL. So I already have a Git repository set up. I'm going to copy the URL from there. And you can paste the URL here to generate a key. This key is what authenticates AppSmith with your Git repository, and you can go ahead and add it in the settings section of your repository. So underneath deploy keys, you can add a new deploy key with a title. And remember to always mark it to allow write access. Great, now that our deploy key has been added, we can go ahead and initialize our repository. So at this step, AppSmith is now initializing your repository with your initial commit, and I'm going to add bootstrap new dashboard. So this will create the initial commit and push it to our Git repository, and we can now refresh our repository to see the updates. So here we can see that actual code has been committed to the repository with a really nice README, and we can even go ahead and create multiple deploy branches. So If we're not happy with the current branch, we can create a staging branch to fork out from, and then go create updates on the staging branch, and then go ahead and even raise pull requests from this new staging branch so that all of your teammates can go ahead and approve those pull requests. So here we're going to make a small change to our application. Let's maybe reduce the height of this particular table, or rather the width, and let's deploy it. So now on deploy, I'm prompted to add a new commit. So I can say reduced height of the, reduced width of the table, and let's commit that. And we can see that a new pull request has already been prompted here. So raising a pull request to master now. We are able to see all of the changes that happened in the last commit. We can see the history of commits as well as what exact changes were made. Your teammates can now review these changes, approve them, and merge them in. And once these are approved, they can be merged in directly from the interface as well. So we can merge staging to master. We automatically look for safe merges. And once you merge, automatically these changes are going to be deployed on top of your master branch. So now that it's been merged on master, we can go and refresh our page. And we can see that the new changes are already reflecting. So just like this, AppSmith does not sit outside of your development workflows. It sits directly inside because it can integrate with all of your CI/CD, your code review processes, and any other Git stream that you're kind of created. That was my session for today. Thank you all for taking the time to have a look at my demo and presentation. I hope you've learned a little bit about low code, and I do hope you'll check out AppSmith to see how it can help you improve all your engineering processes.